So, good late afternoon, everybody. It's great to have you here back. And also the people who are looking the video, it's nice you are still following the meeting. And we have a panel, and there are two topics in the panel. So what kind of competencies are needed in careers, in private sector and industry. And of course, now we are discussing from the STEM, science, technology, engineering, math point of view. And then another question about expectation of the input from school science education. So what school science can do in order to support the learning of those competencies. And in our panel already Professor András, Patkós have been introduced, so I will not introduce you once again. But we have Helin Semilarski, and he has been working as a teacher for 6 years and defended just recently, a couple of months ago, and now she's continuing as a postdoc. So we have a teacher view and postdoc view in our panel. And then we have Dr. Katrin Vaino. She defended some 10 years ago in science education, so both Helin and Katrin are from the group of MIA. And she worked then a short time in Helsinki as a postdoc, but also in Sweden in Umeå, and now back again in Tartu University as a researcher. And then we have Professor Roland already introduced, so we are almost ready. Maybe I should introduce myself. I'm working as a professor of science education at the University of Helsinki. So I have 3 questions. They are coming to the screen, and we agree that about 3 minutes everybody can maximum use for answering the questions. I think that almost all the issues have been discussed. I was thinking that we are answering in the panel, so maybe it's more like summarizing issues. So what are these high-level experts in our panel, how they are summarizing what we have learned today? So my first simple question is that what kind of competencies teachers should emphasize in science education, and from the point of view that they are really needed in labor markets. So should we go in somehow an order? Maybe we start with Roland, and please, can you summarize?
Okay. So thank you for this really good question. I think this is a $1 million question, this is we say. When I look at the students in school and I imagine them as adults, and I think what I would like to see when they graduate the school system, and when I look around what happens in the media and in the streets in Israel and all around the world, I would like to see our graduates able to see the data, available data, to analyze it, and to reach into conclusions and to build their opinion upon this. Instead of saying, I don't believe in climate change, or I believe in climate, I don't, this is, or even I believe in climate change. I would like to see, these are the data. We see the data regarding the carbon emissions, and when I analyze the data, I realize that there is an increase of carbon dioxide in the atmosphere, and I realize that we should reduce the use of fossil oils. And this is an example. I would like to see our graduates be able to argue with other claims using authentic data that they analyze and reach into conclusions. And this is not against, but this is in contrary to what we see in the media and in the newspapers, that people really believe in something and fight for it, but they don't even check what is the resource for this opinion. And later in the panel, I will also talk about student agency, because when you have a well-based opinion that is based on data that you analyzed, you can also develop your agency to change the situation and to act upon the results that you found. And this agency, students or adults or citizens with agency, this is something that I would like to see in the future of our globus. Do I still have time?
Thank you. So,
no.
Katrin, please.
First, I would like to intrigue a bit, and for me at least, the idea that general education and labor market are in the same sentence sounds a bit too neoliberal, but there is no wrong answers, questions. There could be wrong answers maybe. So it can be questioned. But in terms of general education, I'm not talking about vocational education or higher education. We could rather start asking, what is the world? It somehow reflects what you already have said. What is the world we'd like to live in the future, in the near future, in the a bit more far future? Then what could be the society that we would like to live in? We could start from societal needs, the needs of our planet, thinking about our planet, what it needs, and then what individuals in this society could need, like very, very basics, like, I don't know, physiological needs, psychological needs, need for self-actualization, and then having this kind of imagination in our heads to think what could the competencies that could feed this picture, this future picture. And I won't talk about specific competencies, because I know Helin will talk about, but if you take this competence as a whole, any competence, then there are knowledge, skills, and values. And there is one aspect that is definitely too less emphasized. It is values, beliefs, let's say intellectual virtues even, like open-mindedness. It was said by Marianne before, open-mindedness, curiosity, honesty, even intellectual humility, that I am skeptical towards my own data, I'm skeptical towards the other data, or let's say claims. So, and this has gained too less emphasis in our schools as a goal, no problem. There are only few people who actually deny that it is important. But the problem starts when we start to operationalize the idea, the very general idea. What could be the instructional design that would develop those values and the very needed values and attitudes? And even more important, how we will assess those values. Because without those, let's say, I am proud to say right values, because it's really complicated what is right and what is wrong. But without right values, the knowledge, science knowledge, could be like weapons in the hands of science denials or I don't know, conspiracy theorists, or somebody who is selling crap and talking that, oh, these cures are like everything. So, and the only kind of weak link has been that teachers have implicitly in mind that I need to develop values, the right values, but how to do that? And my message, the kind of positive message would be that we could use affective domain. Krathwohl is a well-known name, but there are others. Also, there is Kohlberg theory of moral reasoning that could be used for building a taxonomy of learning outcomes. And I can say that we have made a small step in our science curricula, which is not actually accepted by government. We are waiting and waiting it, and by our science e-test, national science e-test, like a small step to define learning outcomes that can be assessed formatively, summatively. So,
thank you, Katrin. And Helin, your answer?
Yes, thank you for your really good answers. I tried not to repeat you, but in my case, I wanted to emphasize the need of people who need to identify different kind of problems. Also, they need to know how to solve the emerged problems too, and not only to do it on the paper, but to do it in real life situations too. And I really enjoyed the scheme that Mia presented too about the transdisciplinary skills. I think that these should be emphasized at the school. And what else? I think what helps to, for example, emphasize the skills, more hands-on activities during the lessons, then to think more about real-life situations where they can use their set of skills that they have developed during science teaching. And in my experience at the school where I taught, for example, there were a lot of gifted students. And I think that Marianne, in her presentation, outlined the optional learning materials or the moments as well. And I think that the students should have some possibilities to make different kind of options throughout their studying. Also, what is important are the self-management skills, especially COVID-19 pandemic raised them. Also, right now, it's important to develop these skills throughout the teaching. I like that, Katrin, you finished with assessment that should help teaching too, and needs to help learning. And this should be overlooked too, how to assess other skills, not only how to apply knowledge.
Okay, András, what do you like to?
Okay, I am a technician. I have not much sense to this general setup of different skills. Model building, finding out what are the important data. More and more data we are getting from different sources, and one should be able to find what are the relevant ones, what are behind the dynamics of a firestorm or of a disease epidemic. If you are not able to find those variables, data, which are driving the whole, and then you build, if you find it, a model on it, and then you just compare the outcome from the model with the reality. If you don't have this sort of way of thinking, then you are lost in the mass of the data. And I am sorry to say that fortunately for mathematicians and physicists, they somehow get accustomed to this reductionist approach to the phenomena. They are over-reducing many times, so one should be very critical against these fundamental sciences, but you should appreciate that this is their specialty. And actually, although I don't know whether this is the right place to say, but the entrepreneurs like very much this capability of our students, and I believe that also the wider public should somehow understand that not everything is able to influence the same way a phenomenon, but there are really driving variables, and that we can start to teach in very elementary level already in the school. What I was thinking, just to give a concrete example, there was a big revolution in science when Newton understood that the relevant quantity is acceleration. While until then, you know probably well, everybody was speaking about velocity. So that is just the simplest example to show how important is it to recognize relevance in some part of the data and dependence determined by other variables in a large other part. That's what I can contribute.
Thank you. So in a summary, so those scientific practices, finding out, modeling, checking what is true, what is not true, it looks important to learn at school. And also those attitudes and like agency, I think this belongs to the attitudes who have to have that kind of things, transdisciplinary skills mentioned. But what was interesting, Katrin raised these values we have not emphasized so much. So in German language there is this Bildung idea, so we are not educating young people to the labor market but for life, and that was really, really important we were missing here in our discussion, and we are maybe, at least I am too much neoliberal type of thinker, so that was good to raise. And when I was preparing myself to this panel, I was looking the UNESCO Universal Learning description of the competencies people need for good life. I think that is quite close to the values, and those OECD models and European Union lifelong learning or key competencies, they are more neoliberal type of descriptions. I have been a little bit wondering, nobody has not mentioned so directly those OECD and European Union models, but I think combining with UNESCO model, I think we can find combining this, your answers and those we are more clever. So I skip this OECD model, and we have been discussing about challenges we are meeting in science education, and we are quite easily saying that science is not interesting for our students in the classrooms, and they are not orienting to the science and engineering careers. I take a look for some PISA data. I will show you. I hope that you can also see, but it's behind you. It's a little bit challenging, but you can see here. So what is the situation in 16 years old young people mind? What they think, how willing they are see themselves in the field of science, math, engineering, when they are 30 years old. So unfortunately Israel is missing, because I take only the upper side of the scale, those OECD member states, sorry for that, but we can see that in Finland we are having really challenge. Only 17% of the young people are looking. It's very similar in Hungary. But in Estonia, 25%, it's not so bad. So we should remember that situation in some countries is not so bad. Then I have only Finnish and Estonian data. So in the PISA questionnaire, there is a question that I enjoy acquiring new knowledge in science. And this is the percentage of students who agree or strongly agree. In Estonia, 80% of the young people think they are really willing to acquire new knowledge. Finland is much, much lower than OECD average. I'm happy working on science topics. In Estonia, students are more happy than in Finland. And what is more dangerous is the trend. So in Hungary and Finland, this opinion is going down. So it's coming even more worse. But in Israel and Estonia, the students have made progress. So in the PISA results, the Estonia is nowadays the model for the whole world. And we can see that in science and math, the green line, the Estonia has made progress in the competence. Finland is going down in science and math, so that might be the real serious problem. The topic we have not discussed is the gender balance. How many females are orienting to the science careers and how many males? And actually, in Estonia, in natural sciences and math, 80% of the students who are graduating master level, they are females. In engineering, it's only 20. In Finland, it's 60, and Hungary it is 50. So this gender balance is not yet discussed. Okay, we might be happy in Estonia, in Finland, that there are quite nice number of females, not in engineering, there we have, and in computer science. But then if we look for how the career develops, so in master level there are more females, but when we go to the full professors, this data is actually from Sweden. I was not able to find from Finland. So, but I think the similar situation is in Estonia and Sweden. So this gender balance is not good if we are looking for associate and full professors. And in Nobel Prize winners, it's even worse. Okay, I give you some data. And now I ask you that you can take only one. What is the most serious challenge we have? But you have to tell me also how to overcome it. You take one of those I show you and how to overcome. So maybe we start from the András now and come this direction. Please.
For me, maybe I stay with the women participation in science, because there I have a little bit more information. So the situation is quite interesting. The attraction of astronomy and is quite high, exerted on women. Solid state physics and more, how to say it, more Earth-based sciences not so attractive. So we should be able to understand, and probably it has some sort of psychological background, why this distinction is there. This is one which I can contribute. The other thing, what can we do against of this inequilibrated participation? In Hungary, what we observe, that is something which we inherited from the Soviet system of assessment. This is the Doctor of Science degree. Among the Doctor of Sciences, the number of women scientists is increasing. So definitely it's an interesting tendency that they stay longer and longer. Behind could be that they have an advantage given. So, you know, there are some sort of indicators, publications, citations, and so on. Now, somehow the Academy of Sciences has arrived to take into account the mother's years in case of the woman, because they have to stay home after the birth of their children. So I have also a collaborator who somewhat later go to this Doctor of Science degree, but the Academy gives some sort of, takes into account it. And there are similar things. Also, we have application schemes, stipend schemes for forming your own research group. Now, for women, those which I mentioned, those circumstances, no positively are taken into account. For forming a young researcher group, a woman can do it at age 38 or 40 even, because they take into account the maternity. I think I agree with this. Let me just make my position. And the last thing is, however, that the number of the among the number of the members of the Academy of Sciences in Hungary, it is still a problem. So against the fact that the number of the Doctor of Science, which is a sort of precondition to get a nomination for being elected, still academicians are elected by academicians. And that makes a potential barrier, because most of the academicians are men, and somehow this is a bad positive recoupling. So here there are big discussions within the academy, but still an explicit measure favoring, okay, I can even tell you, there is one decision that if in a competitive sort of election scheme, a woman candidate passes the 50% level, although in the ranking she might be the fourth, then the president of the Academy of Sciences has a quota, a very small quota, 3-4 places. And okay, he decides. He should not tell on which. During the last election this spring, actually he used, I think, 2 places to give them. So that is a challenge which, as an elder scientist, I participate in the discussion, and I see that the challenge is there, people are taking seriously, but to move away from this sort of machoist organization of science takes long time.
Okay, thank you, András, for taking this gender balance. And it is not only in those positions, but we need role models, because role models are influencing very much young people thinking. And if there is only one gender type of role models in kind of high-level positions, so this is a serious issue actually. But Helin, what is your challenge you are solving now?
I didn't focus on the gender issues, but more on something else, yes.
Yeah, please.
On there is lack of people who take as their career opportunity to go on the STEM field and to choose the career from there. And I think the problem is more raised by that, how they have been taught at the school too. For example, if it's not motivating, then it can cause the dislike to choose it as a career option later on. And also, if to compare science subject at school with other subjects, then the content is more heavy and it is abstract in more science fields, more abstract, but that can cause it, the lack to choose it. And also in science education, there is need of supportive assessments too, that can show to the students that they have enough of skills and knowledge to choose the STEM-related career, that they don't feel that they didn't take the test well and they are not good enough to take that career option. I think this is something that can be changed, and also it is something that we can address more, and I can address it.
Yeah, so the cost young people have to pay is very high. And Katrin, what is the challenge you saw?
I picked up young people's willingness to take up STEM studies.
STEM studies, and
Yeah.
what is the solution?
And what is the solution? So I think, and I believe in it very much, that first of all, we have to strengthen young people science identities. Okay, this is just empty words if there is no kind of agenda behind, but we could do that through simply meeting their psychological needs. Three psychological needs: need for competence, need for belongingness, need for autonomy. And the thing that you just said, that they feel in science lessons as kind of inferior because they don't get it, they just don't get it. This is the crucial aspect, how to build scaffolding to students during science lessons. So this has to be part of science teachers' basic schooling or in-service schooling. So this is one aspect. The other aspect is that the meeting, I am of course talking about self-determination theory and their kind of postulates, but which has empirically proven. So this meeting their needs is not only important for raising their motivation and building their identities, that they feel that science is something even for me, let's say, but this is also important for internalization of those values that I just said. There is research behind, but the values or kind of expected beliefs need to be modeled. As it was just said, they need role models. In case it is not modeled, but in whatever format, probably they won't develop that kind of values if there is no family kind of effort behind. And if I may, to make a comment with respect to gender aspect, this is already the other one. No. Okay, I will do that afterwards.
Thank you.
Yeah.
So also quite psychologically oriented analysis, but also the sociological orientation in these role models and gender. And Ron, what you pick?
Okay, so I would like to return to the ideas that I said in the first round about how I imagine the graduate of the educational system, people who know how to base their opinion on data that is validated and they can analyze it. And I think that if we would like to raise people like this with these skills, we should, in order to emphasize these skills, we should change not only the curriculum that will teach them how to do that, but we should also change the whole system. Because if we want that teachers will really do it, this should be also emphasized in the assessment, because teachers eventually teach for the test, because at the end of the school years, the students have to take the external assessment, the matriculation exam in Israel, for example, and teachers are responsible for the success of their students. So if we appreciate and evaluate certain skills like argumentation, database argumentation, this should be part of the external exam. This should be part of the curriculum. This should be part of the teaching. So only when we will conduct a systematically change, we will be able to see a difference at the end of this process. And I would like to connect it to something that I saw in Poland. A year ago, I visited there the educational system, and they wanted to improve their results in the PISA test. So they changed the assessment, the national assessment toward the PISA test, namely reasoning and base their opinion on analyzing the data and base their opinion on the data. And very fast, they really improved their results in the international PISA test. It means that when you want to do a change, you should look at the whole picture, change the assessment, change the curriculum, and change the teaching.
Yes, assessment is driving the system. In Finland, we changed the matriculation examination computer-based, and now every student in upper secondary school is using all the time computers in learning. Maybe it's not good, but that was a political. So you can change assessment and you change the system. Okay, we have almost used our time, but Mia gave us some extra time, and actually my last question is not necessary to answer in order, so those who are most willing, they can start, and let's have a look if we have time for everybody. But anyway, actually, Katrin and Helin start my last topic somehow. So we have not discussed today so much about the kind of research frameworks for making research on what makes science more attractive, what makes science careers and studies more attractive. And of course there are many frameworks, and quite commonly used are those sociologically oriented, and Katrin mentioned about those role models and gender, maybe they belong to that type of orientations. And then Katrin mentioned also those self-determination theory issues, the competence and autonomy and relatedness, and Helin mentioned this expectance value theory related issues related to the cost. The cost is too high. So if we are now starting our serious research on the topics we have been discussing today, so what to pick as a framework? So I have a couple of ideas in those sociologically oriented frameworks. So the role models are important, and how the young people perceive the prestige and the work conditions, and it is also known that it's quite young people, 9-13 years old, develop kind of attitude to the career and the role of families. We have not discussed about families here. That is important. And then Mia and me, we participate to the Rose study, and as a part of the Rose study, we become familiar that how the social position of scientists and engineering have been weakening, and lifestyle. Somebody mentioned about the hard life, and it's not so attractive. Low status relation to the workload. So that kind of issues belongs to the sociologically oriented. And for example, Jackie Eccles have made research on starting from the more psychologically oriented theories, and this is kind of big picture, but maybe we can take only these main ideas in the expectance value theory. So the intrinsic value, enjoyment of liking and utility value, attainment value and cost. So what do you recommend as a panelist for how to orient to this type of research seriously, starting from more sociologically oriented or more psychologically oriented? So who's willing to start? I ask, who's willing to start?
I can try.
Okay, Ron, please start.
I think one issue related to science learning is the thinking of some of the students and the teachers that you can understand science or not. It's either you have it or not. And I'm more trying to target regarding more a growing mindset. It's not that someone is born to understand science and mathematics and someone doesn't. if you try hard enough and if you persist and try again, you will be able to learn. And I think when teachers and students realize this or adapt this approach of growing mindset, things will look differently. Because if there is a question in geometry, for example, at the first time I will not be able to solve it, and then I will look at it again, and then I will try again. And every time I try to solve a problem, I improve my understanding and my knowledge. And this is how it works in the real world. It's not that people go to a problem and solve it because they are genius. They look at the problem, they examine it, they talk with others about the problem, and then slowly, slowly they reveal parts and aspects that they didn't see in the first time. Maybe they think that the problem should be defined differently, and then they try to solve it. And I think that the growing mindset is really something that is very important in science and mathematics in school. And it also reflects how science is really done in actually labs, because if we look at real problems that scientists solved, it was never at the first trial. What you solve very easily, it's not really interesting most of the times. Things that are really a puzzle, and you have to think and to collaborate and to try different theory to approach them, these are the really interesting problems. And I think we can educate the students from a very early age not to leave the problem if they don't succeed to do it at the first time. And also to learn from the mistakes, because every time you do a mistake, you can learn from it and get better and better. And I think this is something that the educational system needs to think how to adopt this approach more deeply.
Thank you. So the mindset type of research is needed. One of my PhD students is making that type of research in upper secondary school, so I know something. So, okay, please, Katrin.
I am not that familiar with ECLA's framework, but we have been using Lent social cognitive career theory. They have both common elements. There is something that relates self-efficacy as well, and you just taught something related to that. So, and we found, it was some years ago already, we studied what factors or what aspects predict their career goals in not science, but technology and engineering. And self-efficacy was always, through different studies, it was always a kind of significant factor for both boys and for girls. But for girls, and there is also one aspect related to parental, I'm not that sure about ECLAS, but probably there is also parental expectations. And we found that for girls it was much more important than for boys. So girls kind of take account their opinion more than boys as an average. So this was kind of an interesting finding, but probably not a very unique finding, because the other studies said it too. So what kind of framework do you like to prefer? This is really difficult question. I guess it's quite complicated. I mean, this ECLAS framework, but it really comprises well the thing. If I remember correct, and if we used Lent social cognitive career theory, which is derivative from Bandura's theory, then the model described quite well their career goals. It was 60 for girls and 80 for boys even. And in other studies it was lower. So I think this was quite a respectable framework.
But it sounds more like a sociologically oriented.
Yes, self-efficacy, interest in...
more psychologically.
Yeah. Yeah.
Combining them.
But social supports and social barriers
rules,
as well.
yeah.
It was kind of combination of.
I will support your ideas about the equals, and I think it's important to start from the liking and enjoyment of the learning process, that the students know how to learn, they like to learn, and based on that you can add other steps to it as well. For example, how to make the difficult parts of the career more better to enjoy even these. And yes, I think it's something that should be addressed more, the enjoyment and liking.
Kind of intrinsic values are driving human beings, so the psychologically orientation you recommend. András, you would like to make comment?
I am contributing the pedestrian approach.
But you already analyzed this gender issues,
yes,
the role models, and
you think
sociologically.
you are fully right, because the idea I got is actually also relevant to the gender problem. I believe that the social status of the scientists in the past 2-3 years has increased immensely. Never before you have seen on the TV or whatever in the public so many scientists giving their lecture and giving their explanation and even trying to influence the public concerning how to behave under this epidemic situation. Only scientists could give something, although they were discussing among each other, but they had a sort of a really exceptional status in the public. So it would be very interesting sociologically, because you were referring to some older investigations, to see what happened now. And back to the gender problem. In Hungary, I have forgotten to tell you the name of Katalin Karikó, who will give an immense push to the interest of younger girls towards scientific professions. So the importance of the personality, of the individual achievement is extremely, the influence of the individual achievement is extremely high, and since the personality of Karikó is quite direct, quite friendly, I believe that she had quite positive influence on the choice of the young girls towards scientific careers.
Thank you. So Mia gave this 10 minutes extra time. There is 2 minutes left. So if there is an audience, somebody would... Okay, Rahel, please. Microphone, please.
Yeah. What I mean, the gender, I just would like to add, it's now a problem which, occupies a lot of people. There was a global survey about the case of gender, and there were there are quite a lot of projects now trying to encourage women in this issue, and one of the conclusions, I don't want to take all the time, was that, as Ron said about something else, it needs a systemic, change. It should come from the policymakers down. And it's not a matter of women, it's a matter of society. It's a matter of family. It's something that has to bother everyone, because you have so many talented PhD students who finish with a very, very high scores, and afterwards it drops. So it means something. So you need to be a superwoman sometimes in order to succeed with your children, family, but again, policymakers need to understand it, and husbands, families, and everyone. So this is part of what is now encouraged to do in Israel and with forums and everywhere in the world.
Okay, I would like to thank you for the panel. You were following the schedule and you were giving good answers. I'm sure that the audience benefit of your analysis. And now we are coming to the next phase. And so you can leave your position, go to the audience back. So thank you.
Thank you.
Thank you.